Have you ever wondered about immortality? This tantalizing concept has captivated the human imagination since time immemorial. From the ancient Egyptians' belief in the afterlife to the mythical fountain of youth, from the alchemist's pursuit of the philosopher's stone to the modern quest for biological immortality, the desire to elude death is a common thread that binds us all. We dream of living forever, of experiencing the unfathomable depths of time, of witnessing the evolution of civilizations. The notion of immortality, however, has often been dismissed as a mere flight of fancy, an impossible dream that contradicts the fundamental laws of nature. But what if I told you that immortality might not be as far-fetched as you think? Enter the world of quantum immortality, a realm where death may not be the final frontier it appears to be, where the end might just be the beginning. This concept, as mind-boggling as it might sound, finds its roots in a well-established branch of physics known as quantum mechanics. Quantum immortality is a theoretical construct that has been nurtured within the cradle of the many worlds interpretation of quantum mechanics. This interpretation suggests the existence of an infinite number of parallel universes, each representing a different possible outcome for every event that has ever occurred. Now let's introduce some key characters who have contributed to this fascinating theory. First, we have Hugh Everett III. A man whose name is synonymous with the many worlds interpretation. Everett proposed that every quantum measurement causes the universe to split, creating a copy where each possible outcome occurs. Then there's Max Tegmark, another significant figure in this narrative. Tegmark's work is often associated with quantum immortality, although he has distanced himself from the concept. He emphasizes the natural process of decreasing self-awareness before death, rather than the idea of jumping between alternate realities to avoid it. The concept of quantum immortality suggests that you, as a conscious being, may continue to exist in one of these alternate universes after experiencing death in this one. It proposes that your consciousness might simply move from one universe to another each time you face a situation that could lead to your demise. But the question remains, how does this quantum immortality work? Is it a mere theoretical conjecture, or does it have some concrete basis in the principles of quantum mechanics? And if it does, what are the implications for our understanding of life, death, and the nature of our existence? Intriguing, isn't it? But how does this quantum immortality work? To understand quantum immortality, we first need to grasp the many worlds interpretation. Now let's break this down. The many worlds interpretation, in its simplest form, is a bold and mind-boggling concept that suggests every decision you make, every path you choose, creates a new parallel universe. Imagine you're at a crossroads. In one universe, you take the left path, in another, you take the right. It's like flipping a coin, where both outcomes exist simultaneously in separate realities. It's as if the universe is constantly branching off into these infinite possibilities, creating a vast, ever-expanding multiverse. So how does this tie into quantum immortality? Here's where things get even more fascinating. Quantum immortality rests on the idea that you, as an observer, continue to exist in these alternate timelines even after experiencing death in one of them. Picture it like this. You're on a journey across these multiple universes. In one, you might meet an untimely end, but quantum immortality suggests that your consciousness doesn't just vanish into the ether. Instead, it simply hops over to another universe where you're still very much alive, continuing your journey, none the wiser of your demise in the previous universe. This is where the thought experiment of Schrödinger's cat enters the picture. In this paradox, the cat inside a box is both alive and dead until observed, illustrating the concept of superposition in quantum mechanics. Similarly, the idea of quantum immortality proposes that we're both alive and dead across different universes, and we continue to exist in the universes where we're alive. So in essence, every time we die in one universe, we continue living in another. This sounds fantastical, but let's see how it could potentially play out. Let's borrow a page from Erwin Schrödinger, the physicist known for his famous thought experiment involving a cat. Yes, that's right, we're talking about Schrödinger's cat. Now imagine a cat, a flask of poison, and a radioactive source are placed in a sealed box. If an internal monitor detects radioactivity, the flask is shattered, releasing the poison that kills the cat. The Copenhagen interpretation of quantum mechanics implies that after a while the cat is simultaneously alive and dead. Yet, when we look in the box, We see the cat either alive or dead, not both alive and dead. This poses the question, when exactly does quantum superposition end and reality collapse into one possibility or the other? Now let's connect this to quantum immortality. Proponents of this concept argue that in the context of the many worlds interpretation, every possibility is realized in some world. When the box is opened, the observer and the cat split into an observer seeing a live cat and another seeing a dead cat. This is a critical point to grasp. The observer now exists in two realities, one where the cat is alive and another where it's not. But here's where it gets even more interesting. Apply this idea to yourself. Every time you face a life-threatening situation, there's a reality where you survive and another where you don't. But since you can only be conscious in the reality where you're alive, you'll always find yourself in the timeline where you continue to exist, no matter how many near-death encounters you have. This is the essence of quantum immortality. It's the notion that you, as a conscious being, will always find yourself in a reality where you continue to exist. But as with all theories, quantum immortality has its critics. While quantum immortality doesn't violate known laws of physics, it has its share of skeptics. To some, the theory is a tantalizing glimpse into the interplay of quantum mechanics and consciousness. To others, it's a philosophically charged conjecture built on shaky assumptions. Let's dive into some of the criticisms. Quantum immortality hinges heavily on the many worlds interpretation, a perspective not universally accepted among physicists. Critics argue it makes assumptions about the nature of consciousness and its ability to leap between parallel universes, which, while fascinating, lacks empirical evidence. A major criticism is the potential conflict with causality, the principle that cause and effect govern the universe. If consciousness could jump to another universe upon death, it would seemingly violate this principle, as the cause, death, wouldn't have the expected effect, cessation of consciousness. Even Max Tegmark, a physicist often associated with the theory, has distanced himself from the concept of quantum immortality. He emphasizes the natural process of decreasing self-awareness before death, suggesting that there might be a natural limit to the survival of consciousness, even in a quantum multiverse. But it's important to note that these criticisms don't necessarily debunk quantum immortality. They simply highlight the challenges and complexities involved in its understanding and acceptance. Quantum mechanics is a field that continually defies our intuition and forces us to reconsider the fundamental nature of reality. So while we can't confirm the existence of quantum immortality, it's a fascinating concept that challenges our understanding of life and death. It invites us to explore the unknown, to push the boundaries of our understanding, and to engage in debates that enrich our view of the cosmos. Whether or not quantum immortality is a reality, it undoubtedly adds a captivating dimension to our quest for knowledge. Quantum immortality, a theory that both fascinates and baffles. We've delved into the heart of this concept, a thought experiment that pushes the boundaries of our understanding of life, death, and existence itself. It's a theory rooted in the many worlds interpretation of quantum mechanics, suggesting that we may continue to exist in alternate timelines even after experiencing death. We've discussed the proponents who argue that quantum immortality does not violate known laws of physics, and the critics who question its assumptions and implications. The debate continues, as does the exploration into the fascinating and often bewildering world of quantum mechanics. Remember, it's the likes of Hugh Everett III and Max Tegmark who dared to delve into the unknown, who have brought us such fascinating concepts. They remind us of the importance of challenging what we think we know and pushing the boundaries of our understanding. So while we may not have the answer to immortality, it's theories like these that keep pushing the boundaries of our understanding. Until next time, keep questioning, keep exploring,